I'm going to run a presentation today that's a little bit different than others I've done in the past, where I'm going to make it, I don't want to say interactive because I can't get feedback from you all right now, but a little bit more dynamic, where I'm going to talk about various concepts related to adopting Istio in production. And we're going to use a diagramming or architectural drawing type of approach to this, along with live demos. So let's get started and see how it goes. So my name is Christian Posta. I'm the global field CTO here at Solo.io. And at Solo, we're working on building technology on Envoy proxy and Istio and WebAssembly to connect your applications, manage any of those APIs that you might be running inside of those deployments, and then run those on any cluster, number of clusters, clouds, or whatever, and simplify the whole experience. I'm currently writing Istio in Action, which is a book from Manning Publishers. And what you'll see is the content from this talk is slow. Some of it's taken from the book that I'm working on. Some of it's taken from various workshops that I've done, including a new workshop that we're going to run for the first time on March 9th that is specifically oriented around Istio Day 2 operations, and we'll go into a lot of hands-on detail. It's free. I'll lead it. And you'll get a little bit more experience. So the things that we have learned in the field working with customers around the world with Istio. So let's get going here. There will be live demos and so on. So let's see, why can't I drag this? There we go. All right. So I'm going to start kind of at the high level, but we're going to quickly drop into various details of what we're going to cover today, which include things like deploying the control plane in a way that makes it operatable or operable. So following some of the default install guides on Istio will get you a good POC environment, but what does it look like to actually install it, deploy workloads, create gateways, secure the mesh with Istio provides this mutual TLS capability, but there are some inherent things that you might want to explore or change about how it manages the CA signing certificates and so on. And then lastly, we'll take a look at expanding out to VMs and using some of the capability that comes in Istio 1.8 and 1.9 around DNS. So let's get to it and let's see. The first thing that I want to point out is how a service mesh is used to help solve some of the same challenges that we've seen in the past. So it's not the problems that we're solving with the service mesh are not entirely new. They're just reimagined, right? So we're deploying into cloud infrastructure that's highly dynamic, and workloads are coming and going and scaling. And the network is unreliable. We know that, but even more unreliable. And where we've tried to solve this in the past was using things like API management or ESBs and so forth. But even in the API management case, what we saw was, traffic would flow into the system as we might expect from the edge. But what we saw is that workloads inside the organization wanted to take advantage of the same capabilities like routing and security and some of the telemetry collection. And to talk to another service, it would actually call back into the gateway and continue to do that, to the extent that this API management piece, which wasn't really built for cloud and dynamic environments, became a big bottleneck, right? And so the alternative is to, instead of having these large centralized things through which all the traffic would be tried to force through, what we want to try to do is decentralize those operations and those enforcement points and telemetry collection points and so forth, and run that across multiple different clusters, multiple different clouds, deployment targets, and so forth, where you might still have something acting as an API gateway, or you might push API gateway functionality down to the clusters to get a completely decentralized view. And now when the traffic comes in, into one of the clusters, the workloads are talking directly to each other, and policy is being applied in line with the request and not forced out through the back up through the gateway like you may have seen in the past. Right. So the service mesh provides a piece of the puzzle to help decentralize policy enforcement, telemetry collection, security around these APIs, and do that in a way that's fit for cloud-based deployments, like those you would see in containers and in Kubernetes. So you say, okay, well, that sounds good. Now, I do want a service mesh. Maybe I do have this problem where we have this large-scale set of heterogeneous applications written in different programming languages, and we want to provide a platform service to the users of our system that solves for these types of problems uniformly, regardless of what language or framework that you're using. So what do? You look at the various different Istio implementation or service mesh implementations. You find that Istio is one of the most dominant service meshes that's actually deployed right now, but there's others, and you can go look at those. But what the service mesh does is it puts these little proxies, these little agents, with your individual services, right? So you might have, let's see if I can do this. Right, we put the Envoy proxies, or a proxy in this case, if we're talking about Istio, it is Envoy proxy, next to the workloads, which there are the enforcement points. That's where we can do things like telemetry collection or security enforcement and so on. But something needs to manage these Envoy proxies, right? So Istio actually is made up of two distinct sections, right? The control plane, which you install and is what the operators and users of a mesh use. You write your configs to the control plane. The control plane then synthesizes those configs into config that is native to the proxy, right? And so what we're going to see is in this first demo is how to get started with the service mesh by installing the control plane first. All right, we're not gonna disturb any of our workloads. We're gonna install the control plane and ideally install it from a day two, let's say, perspective, knowing that you're gonna have to operate and maintain this thing into the next versions and upgrade it and patch it and so forth. So let's really quickly take a look at what that looks like. Now, if you go to the istio.io website, the way you install Istio is pretty simple. IstioCTL install, and that'll install the default profile, and that should be good enough to get you up and running. But what we're going to do here is take a slightly different approach. We're going to install the control plane first. So Istio's components are mix and match and interchangeable. You don't have to adopt all of the components at once. You can start small and start to iteratively grow into the rest of the capabilities that you need, and that's what we're going to do here. We're going to use this particular configuration file, and we're going to create the Istio system namespace, and then we're going to install the Istio control plane. Now, one thing you might notice here is I'm using a config to the install called revision. So a revision allows us to version our control planes and Istio components in general separately from each other, because if you're an operator of a system, a service mesh is a critical piece to that how the system operates. You're going to be patching it and versioning it, upgrading it, and so forth. So let's start from the beginning with that in mind. Now, one of the problems with this particular functionality is still being ironed out upstream, and I'll give you an update on something that'll change in a second. But one thing that we'll see is if we take a look at the logs for our Istio control plane, which we see here, So in our Istio system namespace, we have the control plane. But if we take a look at the logs, there's one little thing that we're just unfortunately going to have to work around. The revisions capabilities needs a little love, like I said, but that's okay. We're just gonna we'll work around it because we know we need this capability, and we'll just create the Istio system service, which will then solve this problem. So let's go ahead and take a look at that problem. Should be gone now. We should see, there we go. Things are ready to be pushed. We're not seeing the validation controller error anymore. And so this is an important first step. So if we take a look at our namespaces here, we have Istio in action. All right, we have our apps running here. If you're familiar with Istio, you would typically see 2 out of 2 if there's an Istio sidecar proxy. There's not an Istio sidecar proxy here. And like I said, if we look into Istio system, we have the control plane up and running. Now, let's come back here, see if I can drag this back. So I mentioned the control plane part, and we installed using revisions, and that will allow us to eventually do upgrades, canary-based upgrades, where some workloads will be managed by one control plane, and some workloads would be managed by a different control plane, and then you're in control of slowly rolling that traffic over from one control plane to the other. All right, so there's this revisions feature, and the idea of this running side by side is intended to give you the most control over how you do your upgrade. Now, that same approach is also used at a different level to introduce workloads into our service mesh. All right, so if I come over here, let's see. Oh. What we're going to do is we have our workloads already running in Kubernetes. What we want to do is slowly introduce some of these workloads into the mesh, and then take advantage of things like telemetry collection or security, or these types of things. So first of all, let's make sure that our applications are working correctly. So if I go into one of the pods and start calling them, we get responses that end in HTTP 200, so that's good. Now what we're going to do is we're going to label the namespace that has these workloads with the correct revision for which we want the right control plane to inject the right proxy. Next, what we're going to do is we're going to deploy a canary version of our app. And what this is going to do is create a new version of our app that should have the sidecar proxy. We can see it running here. And from here, we want to go back and verify, all right, we have some web API deployed with the data plane, some without the data plane. Let's go make sure everything is okay. And if it's not, then let's roll that thing back. Let's get that out of there. Right. You can verify that the traffic continues to work and so forth, and then introduce the data plane into the original deployments, or do a rolling restart of the original deployments. Now, this is one approach, right? This is not the only way you can introduce the data plane into your service. You can use Kubernetes canary rollouts. You can use Istio's manual sidecar injection. So there's a few different approaches here, but the idea is slowly introduce the proxy into this service. And so now we restarted, but once you're confident that it's working, then roll the rest of them out, and then you can either pull the canary out or get rid of the original deployment and scale out the canary. But so this is one way to iteratively introduce the data plane and do so in a way that's safe. You're able to recover from it, roll it back, and then if everything looks good, then let's just speed it up and restart all of the workloads here. Istio in action. We can see that now they're all being rolled, right? And it's because we labeled the namespace with the correct revision that the Istio sidecar injector knows which version of the data plane to inject. All right, so that's all good. Let's come back here, because now we got to think about how we're going to expose these applications, how we're going to allow traffic from outside of the mesh or outside of the system into the mesh. So if we take a look at one of these examples, so we have approximately this deployment right now, right? We have the control plane, it's managing the data planes, services when they communicate with each other, they're going through this decentralized, Envoy architecture. And so what we're going to do now is we're going to add some way for traffic to come in from the outside and into the mesh somehow. What we're going to do is we're going to install a ingress gateway, Istio ingress gateway, that is. And the way we do that, and you'll notice, is we're going to, again, decouple and separate that out from the rest of our Istio installation. When we install Istio, we just install the control plane part. Now, for reasons of upgrade and not having things too tightly coupled, we want to separate how we upgrade the gateway as well. So let's take a look at doing that. So we're going to use the same Istio operator configs, or similar Istio operator configs, for installing the gateways. And we're going to start with an empty base profile. In the previous one, when we installed the control plane, we said minimal, so that we can add and configure and do, control the control plane configuration as much as we can. Here we're going to start with empty, and then we're going to add the Istio ingress gateway. Now, this will be installed separately, as you can tell, from the control plane. So if I started doing control plane upgrades, I'm not going to take down the gateway also, which might be serving live traffic from clients outside the mesh. Right? So we want to treat those completely independent. So if we look at the control plane namespace, we don't see, we just see the single control plane instance there. Now we're going to install the ingress gateway. We're also going to give it a revision so that later on down the path, when we start doing upgrades, we create a revision of 1.9, let's say, we can slowly control how traffic gets shifted from one version to the other. So let's go ahead and install that. Yep.
Sorry, is it possible for you to make the font a little bit bigger on the terminal?
Yeah.
Awesome.
Yeah. Thank you. Yep. All right. Hopefully that is a little bit better. So now, if we take a look at the components running in the Istio system namespace, we see that we have our control plane running, as well as our ingress gateway running. All right, I can make it just a tad bigger then. Okay.
That's way better. Thank you.
Okay, awesome. Yep. Now we can see that the service has also been exposed on a cloud load balancer here. And then what we're going to do is we're going to expose our application. All right, so we're just going to look at simple virtual service and gateway resource. So for those of you that are familiar with Istio, these are how we can expose ports, open ports, and expose service routing for traffic to come into the mesh, into the system here. So let's just go ahead and apply that. And now we should be able to call our service by calling that IP address. That went a little fast. By calling that IP address, and now the traffic hits the ingress gateway. The ingress gateway knows how to route it to then the next workloads. Now, another piece that you can do. So the gateway is good at allowing traffic in. There's going to be typically some requirements about what traffic is allowed to be let in and which traffic is not allowed to be let in. Istio has an approach for doing some of that, at least, which is writing authorization policies and and other policies about what traffic should be rejected if it doesn't contain specific, let's say, tokens or users, or these types of things. So what we want to do is, if the request coming in contains a JOT and is approved by the the issuer of that token is approved in our configuration, then we'll let the traffic in. Otherwise, we'll block it if it doesn't have an approved JOT, or if it doesn't have a JOT at all. All right, so that's one example. We can do other things like apply CORS policies, so that if we're using browser-based applications, we can specify the correct CORS headers, and so we can do TLS termination or pass through the gateways. We can expose multiple domains and multiple certificates on the gateway. And so the gateway is pretty functional for a ingress gateway, but if you need something more powerful, more capable, then that's probably where you'll look at something like a Glue Edge, or some other API gateway, ideally based on Envoy, in my opinion. So let's take a look at what that might look like. So in Istio, we can specify a request authentication. And a request authentication basically configures Istio to say, hey, watch out for JOT tokens. And we will restrict access to particular services that get exposed on the gateway to those that have valid JOT tokens. So let's apply that. In conjunction with this config, we also need to tell Istio how to allow certain users. And in this case, we're going to allow JOT tokens that have been issued by a certain provider, and we'll apply this policy to the ingress gateway. So I apply this authorization policy. So in this case, if you don't have a JOT, it'll fail the request. If you do have a JOT and it's valid, it'll allow it through. If it's an invalid JOT and so on, it'll fail. Just real quick, we have a number of sessions, and by we I mean some of us folks at Solo. We have the one that I'm doing here. Edith and Yuval will be doing a really interesting one about debugging WebAssembly when you inject WebAssembly into your Envoy proxy in Istio. A customer of ours is doing a really good presentation on their deployment of Istio in a really large scale. And then Wednesday, we'll be doing a deep dive. Lawrence from my team will be doing a deep dive on Istio authorization policies. So this is one of those kind of more complicated areas of Istio security API, and we'll do a deep dive. And if you're interested in multi-cluster type stuff, I think doing a debugging of failures and issues across multi-cluster Istio and so on. All of this based on working with our production deployed customers as we support Istio for them. All right, so we'll give that a few seconds. Let's try to call that service without a token. And we see that it is indeed forbidden. And let's actually pass in a valid token. This might take a little while because the token's kind of large, but we should see then the request go to the gateway. Gateway will evaluate the JOT, validate it, then run its role-based access control against it. And we should see, once this thing's done typing. So this is a live demo, and I just have a script that types this stuff for me. Otherwise, as you can see, it would take a little while. And we see the request went through this time. So the gateway is properly enforcing the authentication authorization pieces here. Okay, that's all good. Now, if we take a look at the, let's go in action. If we take a look at this, we see our workloads, they have the Istio sidecar deployed. The Istio sidecar, including from right here. So as traffic comes in from the gateway, let's just use that last example. The JOT token traffic comes in, gateway does its validation and authorizations, and then passes the traffic off to a different service, which may then in turn also call other services and so on. All of this traffic here is or can be configured to be encrypted, and done so with mutual TLS. Now, Istio is the one managing the certificates that go into these different workloads, and Istio is acting as the CA, and the workloads are basically sending CSRs to Istio. The CA is signing them and then mounting the cert directly into the workloads. And in a default deployment, Istio, what it's going to do is create its own, let's call this a self-signed certificate, and we'll use that as the CA. But there are other, oops, might not be able to see that there. There are other options, however. So in Istio 1.8 and continuing to evolve in 1.9, what we have is the option for the same sort of model, right? The workload will come up, the workload will send a CSR. At this point, Istio will validate that yes, this is indeed a workload that can be run in the mesh and deserves a certificate, and then it will create a Kubernetes CSR, and then it will flow through the mechanisms that Kubernetes allows right now, where you can have various issuers and an approval process and so forth that then allows you to manage the certificate creation, workload certificate creation outside of Istio itself. So that's one approach using the Kubernetes CSR. Another one is it follows a very similar model, but instead of calling out to Kubernetes, it'll call out to a different component that actually speaks the Istio CA APIs, right? So instead of going there, it would go to a different component whose entire job is to do this type of thing. Now, these are all approaches that are available in the community and continuing to improve. One issue that we've run into, a major issue, security issue with our customers, is the certificates for either in the default case or even if you mount it in, the certs here, or even the workload certs that get created here, they're stored as Kubernetes secrets, and that includes the certificates and the keys. Right. So what we need is an approach to, safely issuing a signing certificate, but not store this in Kubernetes secrets where theoretically people can access them. And so one of the models that let's use. There we go. Let's use a real example where a customer of ours, actually a handful, this is a common pattern, customer of ours wanted to store its root CA and keys and so forth into some sort of HSM where it would be stored either offline or not available. But then Vault would be able to issue intermediate signing certificates that another component could use to create certs. And so the way this works is we have a little sidecar that gets deployed with the control plane. And what this does is on startup, it will reach out to Vault and say, hey, give me an intermediate signing certificate that I can store locally, as well as keys, and then the control plane will continue to act as the CA as CSRs come in. It'll just work the same way that it does today. But the key point here being that this little sidecar writes the response. So the response is a key and assert. Writes this into memory, right? For this particular pod. So now the intermediate signing certificates are available, and the normal workload certificate provisioning happens as you would expect in Istio, but everything is stored safe, either offline or in memory, and you don't have any secrets leaked into etcd or into the Kubernetes cluster or anything like that. Why don't we take a quick look at that? And I believe we're running out of time here. So the first thing that we're going to see is we have, if we can, we should see, come on. We have Vault running, and Vault has it's storing the root CA and keys and all that. The first thing we're going to do is look that Istio, when we started it, created its own self-sign certificate here. And if we take a look at the public CA, the root CA, we see that this was issued by that self-signed cert. But what we want to do is we want to install that little sidecar to handle the workflow of getting the keys and the certs for Istio to use. So first of all, we're going to delete that secret. We don't want to use that secret anymore. And then we're going to take a look at how to install that sidecar. So the first thing we'll see is that we're going to store it locally in memory. We're not going to write anything to disk, and we're not going to store anything in secrets. And then the next thing that we will see is that we'll store the that in-memory disk at etc/ca certs, so that when we have the let's find the init container. Init container right here. What we'll do is that will handle the orchestration of the Vault, procuring those intermediate certs and then storing them in memory, or storing them to this location in the pod, but in memory ultimately. So let's apply this. Okay, now we should go get the pods from Istio system and see that indeed we are up and running. And then lastly, we'll take a look at that config map again, the root CA, and we should see, cross your fingers, that it has been issued by Vault, by the PKI that we installed outside of Istio. And now all of the workload certs and so forth will be provisioned with this, or signed with this intermediate signing certificate. So it appears that I am running short on time, but I guess wrapping up. So this has been and the next step I was going to show was the VM integration and DNS, but I don't want to rush it. I want to leave time maybe for a couple questions. But I guess the point is this sort of stuff is pulled from a lot of pain and heartache working with folks, working with our customers in production, running Istio at very large scale. And so this is something that we have a lot of expertise and we can help you with. We offer supported Istio with a long-term support for N-3. We offer FIPS builds of Istio, typical enterprise SLAs, Sev1 SLAs, and so on. This particular content was, as I said, based on the learnings from the field, which we're going to go into much deeper detail, hands-on with our workshop. You can see some of the labs from the workshop, getting familiar with Envoy, not from a hello world perspective, but really understanding Envoy. Envoy is the key to this service mesh technology. And then connecting up to and integrating with your existing observability systems, continuing to onboard services into your mesh, and then of course, how do you figure out when things start to go wrong? So we'll take a look at this. This is part one of this workshop series, and the other one will go into even more detail, like doing things like CI/CD and so on. But yeah, check out what we're doing at Solo. And continue to invest in Istio and using Istio. Istio is the most dominant, most powerful service mesh. So definitely continue on that journey. So with that, I'll leave a minute or so for questions.